Welcome. Today, we're diving into the world of deep learning. You might have heard this term in conversations about artificial intelligence or seen it in the news. But what exactly is deep learning? In this video, we'll break it down in the simplest way possible so you can understand how it works and why it's so important in today's technology-driven world. Let's start by exploring the basics and see how deep learning fits into the bigger picture of AI. Before we talk about deep learning, let's quickly touch on artificial intelligence, or AI. AI is a broad field in computer science that aims to create machines capable of performing tasks that usually require human intelligence. These tasks include things like recognizing speech, understanding language, playing games, or even driving cars. Deep learning is one of the most exciting and powerful techniques within AI, and it's responsible for many recent breakthroughs. Within AI, there's a field called machine learning. Machine learning is all about teaching computers to learn from data, rather than programming them with specific instructions for every task. For example, instead of telling a computer exactly how to recognize a cat in a photo, we give it lots of pictures and let it figure out the patterns that define a cat. Deep learning takes this idea even further. So, what is deep learning? Deep learning is a special kind of machine learning that uses structures called neural networks. These networks are inspired by the way the human brain works. Deep learning models can automatically discover intricate patterns in large amounts of data, making them incredibly powerful for tasks like image and speech recognition. Neural networks are the backbone of deep learning. Imagine a network made up of layers of interconnected nodes, or neurons. Each neuron processes information and passes it on to the next layer. The network learns by adjusting the connections between these neurons, gradually improving its ability to make predictions or recognize patterns. You might wonder why it's called deep learning. The deep refers to the many layers in these neural networks. While traditional neural networks might have just one or two layers, deep learning networks can have dozens or even hundreds. These extra layers allow the network to learn more complex features and representations from the data. Deep learning works by feeding data through these layers of neurons. Each layer extracts certain features from the data. For example, in image recognition, the first layer might detect edges, the next might find shapes, and deeper layers might recognize objects. The network learns which features are important by adjusting its internal connections based on the data it sees. Let's look at a practical example. Imagine you want a computer to recognize cats in photos. You feed thousands of labeled cat and non-cat images into a deep learning network. Over time, the network learns to pick out the subtle features that distinguish cats from other objects, like fur patterns, ear shapes, and whiskers, all without being explicitly told what to look for. Another common use of deep learning is in speech recognition. When you talk to your phone or a smart speaker, deep learning models process your voice, break it down into patterns, and match those patterns to words and sentences. This allows devices to understand and respond to spoken commands with impressive accuracy. Training a deep learning model involves showing it lots of examples and letting it learn from its mistakes. The model makes predictions, compares them to the correct answers, and adjusts its internal settings to improve. This process is repeated many times, gradually making the model more accurate. One of the most important things in deep learning is data. The more high-quality data you have, the better your model can learn. That's why deep learning has become so powerful in recent years. There's now a huge amount of digital data available, from photos and videos to text and audio. Deep learning models require a lot of computing power to train. Powerful computers, often with specialized hardware like GPUs, are used to process massive amounts of data quickly. Advances in hardware have made it possible to train much larger and more complex models than ever before. Traditional programming relies on explicit instructions written by humans. Deep learning, on the other hand, learns from data and experience. This means it can handle complex tasks that are difficult or impossible to program directly, such as recognizing faces or understanding natural language. Let's take a closer look at the layers in a neural network. The first layer receives the raw data, like pixels from an image. Each subsequent layer processes the data further, extracting more abstract features. The final layer produces the output, such as a label or prediction. This layered approach is what gives deep learning its power. Inside each neuron, there's a small mathematical function called an activation function. This function helps the network decide whether a signal should be passed on to the next layer. Activation functions add nonlinearity, allowing the network to learn complex patterns, not just simple ones. Deep learning models learn using a process called backpropagation. After making a prediction, the model checks how far off it was from the correct answer. It then adjusts its internal connections to reduce future errors. This process repeats over and over, gradually improving the model's performance. Most deep learning models use supervised learning. This means they learn from labeled data, where each example comes with the correct answer. The model tries to predict the answer and learns by comparing its prediction to the actual label, making adjustments as needed. Deep learning can also use unsupervised learning, where the data doesn't have labels. The model tries to find patterns and structure in the data on its own. This is useful for tasks like clustering similar items or reducing the complexity of data. Another approach is reinforcement learning. Here, the model learns by trial and error, receiving rewards or penalties for its actions. Over time, it figures out the best strategies to achieve its goals. This method is often used in game-playing AI and robotics. There are many types of deep learning architectures. Some of the most popular include convolutional neural networks, CNNs, for image tasks, recurrent neural networks, RNNs, for sequence data like text or speech, and transformers for language understanding. Each architecture is designed for specific types of problems. CNNs are especially good at processing images. They use special layers that can detect edges, shapes, and textures in pictures. This makes them ideal for tasks like recognizing objects in photos, detecting faces, or even reading handwritten text. RNNs are designed to handle sequences of data, like sentences or audio. They have connections that loop back on themselves, allowing them to remember information from earlier in the sequence. This makes them useful for language translation, speech recognition, and time series prediction. Transformers are a newer type of deep learning architecture that has revolutionized natural language processing. They can handle long-range dependencies in text and are the backbone of many modern AI language models, like those used in chatbots and translation services. Deep learning is all around us. It powers voice assistants, recommendation systems on streaming platforms, facial recognition in smartphones, and even self-driving cars. Many of the smart features we use daily are made possible by deep learning models working behind the scenes. In healthcare, deep learning is used to analyze medical images, predict diseases, and assist doctors in diagnosis. For example, deep learning models can spot signs of cancer in X-rays or MRI scans, sometimes even more accurately than human experts. Financial institutions use deep learning to detect fraud, predict market trends, and automate trading. By analyzing huge amounts of transaction data, deep learning models can spot unusual patterns that might indicate fraudulent activity or help make better investment decisions. Self-driving cars are one of the most exciting applications of deep learning. These vehicles use deep learning models to process data from cameras and sensors, recognize objects on the road, and make driving decisions in real time, helping to improve safety and efficiency. Streaming platforms like Netflix and Spotify use deep learning to recommend movies, shows, or songs you might like. By analyzing your viewing or listening habits, these models can suggest content tailored to your preferences, making your experience more enjoyable. Despite its power, deep learning faces challenges. It requires lots of data and computing power, and models can sometimes be black boxes. It's hard to understand exactly how they make decisions. Researchers are working to make deep learning more efficient and interpretable. One major challenge is the black box problem. Deep learning models often make accurate predictions, but it's difficult to explain how they arrived at those decisions. This lack of transparency can be a concern in critical areas like healthcare or finance. Deep learning models can sometimes learn biases present in their training data. If the data is unbalanced or reflects stereotypes, the model's predictions may be unfair. Addressing bias is an important area of research to ensure AI systems are fair and ethical. Overfitting happens when a deep learning model learns the training data too well, including its noise and errors. This means it might not perform well on new, unseen data. Techniques like regularization and dropout are used to prevent overfitting and improve generalization. Researchers are constantly finding ways to improve deep learning models. This includes developing better architectures, creating more efficient training methods, and finding ways to use less data or computing power. The field is evolving rapidly, with new breakthroughs happening all the time. Transfer learning is a technique where a model trained on one task is reused for another, related task. This allows deep learning models to learn faster and with less data, making them more practical for real-world applications. Explainable AI is an area focused on making deep learning models more transparent and understandable. By developing tools and techniques to interpret model decisions, researchers hope to build trust and enable safer use of AI in sensitive fields. As deep learning becomes more widespread, ethical considerations are increasingly important. Issues like privacy, fairness, and accountability must be addressed to ensure AI benefits everyone and avoids causing harm. The future of deep learning is bright. As technology advances, we can expect even more powerful models, new applications, and greater integration into our daily lives. Deep learning will continue to shape industries, drive innovation, and solve complex problems. Deep learning isn't just about numbers and data. It's also being used in creative fields. Artists and musicians are using AI to generate new works, compose music, and even create visual art. This blend of technology and creativity is opening up exciting new possibilities. Robots powered by deep learning can see, hear, and interact with the world in ways that were once science fiction. From warehouse automation to home assistants, deep learning is making robots smarter and more capable than ever before. Language translation apps use deep learning to understand and translate text between languages. These models can capture the nuances of language, making translations more accurate and natural-sounding than ever before. In gaming, deep learning is used to create smarter non-player characters, generate realistic graphics, and even design new levels or challenges. AI-powered opponents can adapt to your play style, making games more engaging and challenging. Security systems use deep learning to detect threats, recognize faces, and monitor for unusual activity. By analyzing video feeds and other data, these models help keep people and property safe in a variety of settings. The Internet of Things, or IoT, connects everyday devices to the Internet. Deep learning helps these devices become smarter, allowing them to analyze data, make decisions, and interact with users in more meaningful ways. If you're interested in learning more about deep learning, there are many resources available online. Beginners can start with simple tutorials and gradually move on to more advanced topics. With curiosity and practice, anyone can explore the fascinating world of deep learning. To wrap up, deep learning is a powerful technology that's transforming the world around us. From recognizing images and speech to powering smart devices and solving complex problems, its impact is everywhere. As research continues and technology advances, deep learning will play an even bigger role in shaping our future.